Hey everyone. So for today's lesson, I thought it might be easiest to go through an example rather than just give you a Word document of notes. It's a little bit easier to understand what's going on when you kind of see this happen in real time. The good news is today is just using skills that you already have. So today's lesson really is nothing new at all. The only thing we're going to be doing is applying kind of all the stuff we've learned into one problem. This is like the crux of chemistry. This is some real chemistry that we're doing here and some calculations that are done in labs wherever chemistry is done. Okay. So what I've got here are two different reactants, lead-3 chloride and lithium sulfide, and they're going to produce something. All right. So step one, what I'd like you to do is pause the video real quick and go back to a couple of units ago when we were writing and predicting products. And I'd like you to predict the products of these two reactants. All right. I'd also like you up above to jot down the names of all of these compounds. So we're going back to nomenclature as well. Okay. If it isn't obvious already, you should definitely have your solubility chart, and you should definitely have your shaded periodic table. Okay. So what I'm going to do is have you pause the video, grab those materials. While you're grabbing those, grab a calculator as well. You'll need one of these definitely, and I want you to follow along. Okay. One of the easiest ways for you to learn chemistry is to actually do chemistry. So rather than me just sitting here doing a problem for you, I want you to actually do this problem as well so you can see how all the pieces fit together. So pause the video real quick, and then I want you to predict those products and write the names of those products up above. After you hit play again, the answers are going to be up on the screen. So pause now and go ahead and try that out. Okay, so hopefully you had a chance to go ahead and predict those products and write out the words. So it looks like this double replacement reaction will happen because we do get a solid product, which is good. And what you should have gotten was Fe2S3 plus LiCl. Okay. Now, right now, this chemical equation isn't balanced. So why don't you pause the video again, take a second, and let's write this as a balanced chemical equation. Okay, hopefully you had a chance to pause this and then find out that we need 2 FeCl3s and 3 lithium sulfides to give us 1 iron 3 sulfide and 6 lithium chlorides. So we should have the same number of all of those elements on each side. Okay? So now we've got a balanced chemical equation. All right? And last lesson, we talked all about how these numbers, the coefficients in front, they were actually mole ratios. So this is like saying 2 moles of this compound plus 3 moles of lithium sulfide yields 1 mole of iron 3 sulfide plus 6 moles of lithium chloride. Okay. The problem is, in chemistry labs, we very often don't work with moles of stuff. All right. When I say, hey, I want you to get some amount of chemicals, the way I tell you that amount is I usually say use a mass balance and measure something in grams, right? So in lab, it's very easy for us to take a scale, measure something in grams, and then say, okay, this is how many grams of stuff I have to do a chemical reaction. Okay. So for us, last class we did mole-to-mole stoichiometry calculations. This class we're doing gram-to-gram stoichiometric calculations, which actually makes a little bit more sense because grams are what we actually measure in lab, and grams are stuff that we can actually measure with a measuring tool. Moles is much more difficult to measure. Okay, so I'm going to walk you through kind of like 4 problems, but really this is going to be one problem. And the first 3 steps are going to be me showing you stuff you've already done. And that 4th problem is going to be connecting them all. It's a way for us to essentially have a little bit of a shortcut. So I'm showing you these first 3 parts to remind you, hey, you've done this. You have these skills already. Here's how you can do it quicker. So think of this video as a quicker way to do the chemistry that I'm asking you to do. All right. If you prefer to do it the long way, you will still always get the right answer. That's fine. It just takes longer. Personally, I prefer the last thing I'm going to show you. All right. But I'm going to build up to that and explain kind of how I did all of those parts. Okay. So let's say we've got a question or a problem. All right. So here's what we want to figure out. If you have 37.6 grams of FeCl3, how many grams of lithium chloride can you produce? Now, we've definitely already learned about limiting an excess reactants. Okay? So, in problems like this, if it does not specify how much lithium sulfide we have, you can assume we have excess or enough for this reaction to use all of the iron 3 chloride. All right? So, the first thing I'd like to do is try and go from grams of one substance to moles of this substance, because mole to mole ratios are the things that connect the reactant side of the equation and the product side of the equation. All right? So the first step I'm going to do, I'll call this just a little one, is actually convert grams of iron 3 chloride to moles of iron 3 chloride. So I'm going to start with 37.6 grams of FeCl3, and then I'm going to do a fraction. All right. Now it turns out I can get that molar mass or gram to mole ratio from my periodic table. So why don't you pause the video, and I'm going to have you figure out what is the molar mass of FeCl3, and then I want you to figure out, should grams go on the top or bottom here, and should moles go on the top or bottom here if I'm trying to get to moles of FeCl3. So pause the video and let's figure out what ratio we should be using here. Okay, hopefully you had a chance to figure out that the molar mass was 162.2 grams for 1 mole of FeCl3. And the reason I put my grams of FeCl3 on the bottom of this fraction is so that my units, when I do this math, can cancel. All right? So to figure out my answer, all I'm going to do is sorry about that. I realized that my calculator was going to block the word. So I'll just do that off to the side. But so what I'm going to do is take my 37.6 grams, multiply it by 1, and divide by 162.2. And then with proper sig figs, I get 0.232 moles of FeCl3. All right? This is really powerful because this allows me now to go in between moles of one substance and moles of the other. So step 2 is for me to go from moles of FeCl3 to moles of LiCl. All right? This is what we did all last class. All right? So last class, if we started with some number of moles of one substance, we could then use a mole to mole ratio in our balanced equation to come up with the moles of the other. So why don't you pause the video for a second and figure out the mole to mole ratio between FeCl3 and LiCl and figure out which number goes on which side of the fraction. Okay, hopefully you found out that that ratio was a 6:2 ratio, or like a 3:1 ratio. And we put our moles of FeCl3 on the bottom of our fraction because we want to cancel moles of FeCl3 on the top for that number. All right, so what I'll be left with here when I do my math is moles of LiCl. All right, so again, with your calculator, let's do this calculation. So why don't you pause the video and we'll actually do the calculation. Okay, so after multiplying by 6 and then dividing by 2, you should have gotten 0.696 moles of LiCl. Right? Step 3 would actually allow me to answer my end question here. How many grams of lithium chloride do I produce? So now this is grams of LiCl. Okay. Well, I've got moles of LiCl. So I should be able to figure out grams of LiCl. Okay, you've done something kind of like this a little bit earlier. So why don't you pause the video, see if you can figure out how to get to grams of LiCl. Okay. Hopefully you realized that you needed to use your periodic table again and find the molar mass of lithium chloride, because that will give you a gram to mole relationship. All right? When I add the molar mass of lithium and chloride, I get 42.39. And here I'm actually going to put moles on the bottom of my fraction because I want to cancel out moles of lithium chloride. All right? Then when I do this math, 0.696 times 42.39, I should get 29.5 grams of lithium chloride. So there's our end answer. All right? Now that's great, but that took a long time. So what I'm going to do is try and give you a shortcut where you can eliminate a lot of this writing and a lot of that time and do this in just one line. Okay? So we're still going to start with our 37.6 grams of FeCl3. And I'm still going to do some stoichiometry. I'm still going to use a fraction here, right? Except this time I'm going to take all of these steps from above and turn them into one, okay? So if I get stuck, I know mole-to-mole ratios can get me between different compounds in a chemical equation. So my first step, if I see grams, is I'm going to try and turn that into moles. And I know that there are 162.2 grams of FeCl3 for every 1 mole of FeCl3. Now I could do that calculation, which would get me moles of FeCl3. But what I'm going to do instead is say, I'm not done yet. All right? That would give me moles of FeCl3. That's good. Okay? My preference, though, is to get all the way to grams of LiCl. So since this calculation gives me moles of FeCl3, I know I don't actually need to write equals anything. I can just cancel those moles out. So I'm going to put moles of FeCl3 on the bottom here, and that equals 6 moles of LiCl on the top. So if you follow along here, my grams have been canceled here, and units of moles of FeCl3 have been canceled here. So right now this would give me an answer of moles of LiCl. But I don't want moles of LiCl, I want grams of LiCl. So I'm going to do one more step here, and that's that last step we did up on the top. 1 mole of LiCl is equal to 42.39 grams of LiCl. And now my moles of LiCl cancel. So what I've done here is created an equation where I can just do a bunch of multiplying by fractions and end with units of LiCl, because all of my other units have canceled out. Right? I've got grams of FeCl3 on the top and grams of FeCl3 on the bottom. So those cancel. So why don't you pause the video and actually do this calculation and see what you get for an answer. It's important to remember here that anything on top of those fractions you're multiplying by, and anything on the bottom of those fractions you're dividing by. Okay, so hopefully you realized that after you do this calculation, you still get 29.5 grams of LiCl. You get the same answer as this. But what's nice is look how much less writing you had to do, and look how much quicker that took us. All right? So I would encourage you to start trying to learn this process, because this up on top takes a really long time. Right? Both of them are achieving the same goal, but up here takes much longer. So this is taking all of these steps and condensing it into one line. And as long as we understand, hey, grams cancel here and moles cancel here, and now we've got moles of a different chemical and those can cancel here, and we're left with that unit, then all we have to do is multiply by the fractions. And that's going to save us a whole lot of time and a whole lot of extra work. Right? Hopefully this helps. You've got some example problems that you're going to be working on today. So thanks for tuning in, and hopefully you're able to start putting these ideas together. Okay? This is, again, one of those things where it seems difficult at first, but it definitely gets easier the more you practice.